Our final speaker for this session is Steve Hore, who is a project geologist with the Geological Survey of South Australia. And he has been working in the Arkaroola area almost straight after the geology up there was formed. Thanks, Steve.
Yeah, it's my beard's greying, yes. Hi, I'm Steve Hore, Geological Survey. This is some of the work I'm doing in the Arkaroola region with Neville Alley and Steve Hill. If I press the right button. Yeah, Marie showed us where we are, so just relative, we're 600 k's north of Adelaide, 300 k's northwest of Broken Hill. The Arkaroola map painter region, you can see on the, to the right, it's a small exposure of the Greater Curnamona province, so it's a great insight to the geology of the area. Here's a map done a few years ago with a few locations and just highlighting or just actually generalising the geology. There's red rocks, brown rocks and green rocks, old, middle and young. Anyway, so generally that's the area. And what I wanted to show in that slide primarily that it's quite fertile. It's, as we know, it's quite rich in uranium. There's gold, copper, and we have the largest tin prospect in South Australia in that particular region. So that's what that slide showed. So what I'll quickly do is just introduce you to work associated with that area about Cretaceous glaciation, the Radium Ridge Breeches, an epithermal system, and a bit of a summary. And if I do that. So in regards to glaciation, it's well known. We've talked about it a bit before. We've got the Sturtian and Maranoan. And also we have some in South Australia, Permian, and there's been younger ones in Tassie that's been noticed. But in regards to Cretaceous glaciation, here, Africa, Antarctica, Asia, Australia, this is from 1998. And when it comes to Cretaceous, there were some suggestions that maybe in Antarctica and Asia there was some, but not in Australia. Neville Alley and Larry Frakes in 2003 did a publication about location in the northern Flinders about early Cretaceous glaciation. It wasn't widely accepted at the time, so it languished, and maybe one of the reasons that there was a general opinion about that period of time of being hot and humid and things like that. So if you go back into the paleo positioning of Australia, in the early Cretaceous, this is at 120, here's Australia, connected to Antarctica. We're pretty close to the South Pole. Here's the Arkaroola region. We're well within the Antarctic Circle. Here's modern day world, Antarctic Circle, Australia's here. Just combining the two, we can see that in the early Cretaceous, Australia, the Arkaroola region, well within the Antarctic Circle. So this gives an insight to the work that we were doing. Neville approached the survey, and myself and Neville and Steve have been, for the past 3 years, working on the Eromanga Basin sediments, and these locations we've highlighted. His original location of Neville and Larry, but we have these sites with evidence of early Cretaceous glaciation and in drill holes. The work that we've done with this is that we've done, I should look at this one, it's a bit easier. We've done the field sites, lithology, palynology, geochron, and SEM for these sites. And Neville's really got stuck into doing the palynology. He's looked at more than 70,000 paleomorphs, and from that we've worked out an age range for the Eromanga Basin, and we've done some zircon and monazite geochron. And as a result of all that work, with the palynology and geochron in particular, but with all the field site inspections, that we've got at least 2, maybe 3 glacial periods during the early Cretaceous. We've got the Valanginian, the Livingston Tillite. That was the original identification by Neville and Larry. We've proven that up to be Valanginian. We also have a second one in the early Aptian, and we possibly have a third one which coincides with Glendenite. So we have this period from roughly 138 to 113 of a glacial environment, drop stones, tillites and the likes. Just moving on to the Radium Ridge Breeches within the hills of Arkaroola and the Mount Painter Inlier. The Mount Painter Inlier is mostly Mesoproterozoic metasediments, granites and gneisses. The Radium Ridge Breeches are a series of disjointed outcrops over about 40 square kilometres. They've been interpreted historically as hydraulic fracturing, diatremes, tectonic, and when OD was found, it has so many similarities with OD that they started looking at this particular area as a surface expression. The work that we've been doing in regards to this is the fact that we started to conceive and work with an idea that may be a little bit different. Here are some outcrop pictures of it. The clasts, angular and rounded, and dominated by local granitic, anyway, it's a long word, rocks. And the matrix itself, it's a lot of sedimentary features and cross bedding and graded beddings and the like. With Neville in particular, working out on the plains with the glacial sediments and then his 20 years work in Canada on glaciers, we looked a lot closer at the Radium Ridge Breeches and we started to identify a lot of facies associated with glaciation. So we then thought, well, we'll start dating, and when we started dating zircons and monazites, the monazites actually threw up an age of 360 million years old within the Breeches. The zircons generally reflected the 1580, the general local ones, 1580 and older. Within the Radium Ridge Breeches, there's a definitive tillite, which we call the Sprigg tillite member. An outcrop here that's Red Sprigg got a bulldozer one day with permission and exposed. He did, Mark, didn't he? He really did, and exposed that. So this tillite, it's full of exotics and unmetamorphosed clasts. And here in a drill hole, it's about 220-metre drill hole, the tillite comes in a number of horizons. Geomorphology, geochron, the youngest grain within the Sprigg tillite member is 220 million years old. So what we've come up with is that the Radium Ridge Breeches are actually glacial. They have so many facies that we can see within glacial environments. And we definitely, with the Sprigg tillite member, we have a definite lodgement basal till. And the reason that we're seeing the Radium Ridge Breeches is that they were, or these glacial things, that they've been preserved. There's been a subsequent influx of iron, manganese and uranium fluids and some silicification. And we'll just get back to that a little bit later on in regards to that. We'll just move on now to the Mount G Sinter. The Mount G Sinter is just a hill full of quartz, nice quartz crystals. It has epithermal textures, but also it has an earlier monazite association. So the monazite anion is an early phase. The late phase is a epithermal phase and has a number of phases or episodes in between. The Mount G, late phase of the Mount G Sinter cross-cuts that Sprigg tillite member. So the latest phase cross-cuts something with zircons with 220 million year old, that are 220 million year olds. The monazites within the Mount G Sinter also came up at roughly 360. So what have we done, 170 odd there. So what we have the Radium Ridge Breeches and the Sprigg tillite and the Mount G Sinter. When we're saying that they are different types of systems, but they both host 360 million year old monazites. Tying that all together, so what we have here is a the thermal chronology of the Mount Painter area. A lot of work put by different people, including Sandra McLaren, who talked earlier. In her younger days, she actually was into hard rock and she really liked it up there. So we've got a temperature depth versus age here. And here's the path of the Mount G inlier as it moves up, as the rocks lose their temperature. So we have here the 360. So it wasn't a set 360 age for those monozites. It's 330 to 390 roughly. The monozites have fluid inclusion temperature, formation temperature is 300 degrees. And according to the works of Sandra and the likes, at 360 million years ago, the Mount Painter inlier was at a depth of 6 to 9 metres. So those monozites that we're finding within the Radium Ridge Breeches and the Mount G Sinter formed not near surface, but they actually formed at depth. So what we're saying is that the Radium Ridge Breeches are an early Cretaceous glacial event. They actually host monozites which have been transported or inherited by the glacial action. We've gone one step further. Here's the two glacial periods that we've correlated the Sheehan-Tillite member that we have in the basin sediments with the Sprigg-Tillite member and the glacial period here. So the Radium Ridge Breeches are a part of an extensive and protracted early Cretaceous glacial period. And, I can't make time. The Mount G Sinter, people want to argue that it's a very protracted epithermal system, probably the longest on the planet. We do have evidence of monozites at 360. We do have evidence of it being very young because it crosscuts the Sprigg-Tillite member, but if it is a continuous system, that's still something that's debatable. So we have this summary here, and the bottom line is that the Arkaroola Mount Painter area is the only location currently known on the planet with physical evidence of early Cretaceous glaciation. So what does that mean in regards to exploration? We all know that Delamere and orogeny, fluid movements, metamorphism. In the same area, we have a 440 event that happens. We have just to the north recently identified Warney volcanic providence at 140. We now introduce the 360 hydrothermal event, even though we've known about the Springs orogeny and Big Lake nearby. And we suggest that there's a post-Cretaceous event within the areas. So just quickly, I keep saying quickly just to put Wolfgang off. I just say just quickly. So this is typical of in this Mount Painter area of the early days for uranium exploration. The drill holes went through the breccia, the uranium was there, and the granitic basement, and the uranium was always above the unconformity with the basement. And this is what's preserving the glacial sequences. If we go a little bit further regionally, this really complex diagram, you could have an ore body and a glacier. It comes along, knocks the top off and sticks it in the Eromanga Basin or the Murray Basin or something like that. So it's something to look at. It's just understanding your landscape. Wrapping up, Wolfgang. With the World Heritage nomination, we've got an AGS special edition. We've got 20 papers in it, which includes a few. We've got one accepted, submitted, and one that I'm really smiling about. We'll get through. And then also with the Geological Survey, Neville and I, we've got a bulletin in regards to the Eromanga Basin and all the sediments and the glacials in it. Thank you.